In this video, I'm going to explain you how to find the momental ellipsoid. How to find the momental ellipsoid at the center of an elliptical plate. So we are going to prove that the momental ellipsoid at the center of the elliptical plate is given by this. So we will draw first the ellipse. So we consider the major axis as OX as our x-axis. Major axis we are taking as the x-axis, and minor axis we are taking as the y-axis, and this axis we are considering as the principal axis. So the z-axis will be perpendicular to the plate, elliptical plate, and this is also the principal axis. So OX, OY, and OZ are the principal axis. So we know already the moment of inertia about the x-axis. Moment of inertia about the x-axis is mb squared by 5. B is equal to moment of inertia about the y-axis, that is ma squared by 5. And to find this, we can apply the perpendicular axis theorem. So if we know the moment of inertia about the x-axis and moment of inertia about the y-axis, then moment of inertia about the z-axis is nothing but moment of inertia of x-axis plus moment of inertia of y-axis. So we get here m by 5 a squared plus b squared. Since these are the principal axis, the product of inertia will be 0. So we have d equal to 0, e is 0, and f is also 0. So we are trying to put the value in this equation, that is the momental ellipsoid is given by this. So we'll try to put the value of a, b, c, d, e, and f. So we get here this. After that, we can do a cancel throughout with m. So m here will be cancelled. So 5 is multiplied to this side. So we get 5 epsilon 4. Now we have here b squared x squared plus a squared y squared plus a squared plus b squared z squared, which is equal to 5 epsilon 4. Divide throughout with a squared b squared. So I'm dividing here also with a squared b squared, here also a squared b squared, here also with a squared b squared, and this side also with a squared b squared. So b squared will be cancelled. We get x squared by a squared plus a square will be cancelled. We get y squared by b squared. In the same way, this a square we cancel with a square. We get 1 by b squared. Here b squared and b squared cancel. We get 1 by a squared z squared. 5 epsilon 4 a squared b squared. So this here we can see 5 is a constant, epsilon is also constant, a is also constant, b is also constant. The whole thing is constant. So we can replace this with constant. So we get x squared by a squared plus y squared by b squared plus 1 by a squared plus 1 by b squared z squared, which is equal to constant. Thank you.